So here's an amp just come in, Fender Hot Rod Deluxe, and it's humming quite badly. It also sounds rather distorted. Okay, so I thought it'd be fun to show you the repair process. So I'm going to pull the back off and have a look inside. Okay, so I got the back off, the amp is powered up. I'm just going to power it up. As you can hear that that buzz going on there, and what I've got here is a portable signal generator, so I'm just going to plug that into the input and put a signal through it. And it sounds pretty awful, and you might be able to hear that at 50 cycles. It's just running in and out of phase. Either the mains is off or my generator, probably my generator, I would think. Okay, so I'm pretty sure it's this these smoothing caps. Now what I'm going to do now is I've got a little homemade capacitance substitution box. So I'm just going to connect this across this cap. There we go. Absolutely lovely. If I reduce the capacitance on this, that noise is going to come back. Perfect. So that cap needs changing. Okay, that cap is definitely going to want changing, but I suspect that these probably won't be far behind, so they all need to be done. And if you look closely here, these two 5-watt resistors are really stressed. There's 50 volts on the one side of these, and they're dropping down to 15 through this little pair of poor overworked Zener diodes next to these caps. And you can see that the plastic has melted on this cap from the heat generated by the resistors. And if you look closely, you can see the board is actually brown, and probably the tracks are hanging off the board underneath. So this all needs to come out. Now the problem is, to do this, all these knobs have got to come off. All these leads are going to need to be pulled, and the worst bit of all is these rather inflexible cables which run down to the valve bases have all got to be bent down. So this board has got to be literally pushed down and then forced outwards so I can get to the other side of that. I don't like soldering on top of component leads, and certainly not these. And I want to take these off, and I want to fit some metal-clad resistors and I mount them on the chassis so the heat gets dissipated properly, and I may increase the value to lower the dissipation slightly as well. So okay, having now got all the screws and things loose, the board is loose, but it's not going to come out because it's got to be pressed right down. All these cables are quite hard. It's warm, but it's not warm enough, and I don't want all these cables to snap off, so I'll be a world of hurt. So what I'm going to do now is warm them all up slightly with a hot air gun. So I'll come back in a minute when I've done that and I've warmed all these cables. Give me a bit more flexibility. Okay, so I've given those all a good warm, so I'm hoping now I'll be able to push that down and just allow enough. It's a bit of a squish, but there we are. We can get the board out now without... Oh, and oh look, somebody's been at those resistors before. So you can see there the board, those power resistors has been resoldered, so the board is actually damaged. So I think I'm going to remove those and mount some metal-clad resistors actually on the chassis, because they're just going to fall off. Whatever I put on there now is just going to pull those tracks off. Okay. Okay, so I'm going to cut these wires flush with the board. Easier said than done. Okay, the caps are also glued onto the board, so okay, you have to use a a scalpel to just carefully cut underneath these. Cut the glue from the underside and just gently move that, and eventually, there we go. So I'm going to do the same for all these other components as well. So I'll literally just snip the leads off flush with the board. I want to pull them through the other side. They're bent on the underside, so it's not going to come off by trying to drag them through the surface. I'll just cut the glue away. So I'll do this with all the caps. There we go. I've cut those wires off. Give that a pull. There we go. So that's those two removed. So I will now start to fit the new caps. Okay, so the first thing I need to do now is to fit the new caps. I need to remove the old wires. We've snipped off on the top side, so I'm going to use a desoldering gun and just to remove some of the solder. And then hopefully I'll be able to pull those little pins, remnants of. Oh well, they've pushed straight through, so that's good. That's gone the other way. That's good. I'll do the same with this one. There we are, and there's the little thing. The other one's gone through the other surface, so I should be able to do the same with the other ones, which is there. I'll just do this one now. There we are. There's that one gone, and there's the other side of him there. Nice. Free, and I haven't damaged any of the tracks. I've got two more to do down the bottom end of the board. So I'm ready to fit the caps now. I'm going to mark, or rather I'm going to fold the leads while they're on this side so I can see the distance of the holes. So I'm just going to carefully fold the leads rather than keep flexing the board. I want to do this all in one go. So I'm going to measure the spacings and just gently fold up the leads. There we go. So that they will now fit through the top side, and I'll fit all four caps at the same time rather than keep turning and twisting the board. So I've got all the old caps out, and this is a really useful piece of test equipment. It's made by a company called Peak, and this is an ESR meter, and it's really useful for testing caps. A lot of times you can test them actually in circuit. This was the faulty main supply HT cap. So it's still saying monitoring component because it's totally open circuit. There's no there's nothing left inside. I think it's gone. It doesn't show any evidence of leakage or anything, but so here's the new one that'll replace it. There we are. So you can see this is its equivalent series resistance, and that's its capacitance. It's measuring. It's supposed to be 47, and it's saying 42.46, but these things are wildly inaccurate in terms of tolerance. In fact, it's saying there -10 or +30. Well, I think we were -30. This is a 22. This is a new one. There we are, 21.4. 2.2 ohm ESR. If I go to one of the old ones, you'll probably find it'll be just as good. Actually, there's nothing really wrong with these, but it's a good policy to change them all at the same time. So let's just try one of these. Yeah, 21.96, 2.4. Actually, that cap is okay. Well, certainly measuring at this voltage anyway. It's only measuring it at a few hundred millivolts, but it may be a different story at 500 volts. It's working on operating voltage. Okay, let's fit the new ones. As you can see now, I've folded the leads ready. I'm going to just put a little bit of hot melt glue on them when I put them in the board, and I want to do it all in one hit so as to stop flexing those cables that go to the valve bases. The caps are all fitted, all the wires through, so I'm just going to fold these over now slightly. And I'm going to solder them all up. I'll just slip off the excess lead. And that's that section done. My next task is to try and make good this previous repair. As you can see, it's all rather, the board has been damaged quite badly. This wasn't the repairer's fault, this was the fault of the resistors on the surface, which got so hot that it actually causes the board to degenerate. I need to get rid of all this excess flux because it's actually bridging and going across to other tracks, so I don't want shorts, and the stuff becomes conductive after a few years, so I need to remove that. So I'm going to use some alcohol spray, some IPA alcohol solvent, and a toothbrush, and just clean that. And I'm going to cut the resistors off the top side of the board, and I'm going to join wires to them. And I'm going to mount these resistors, but I'm going to mount them on the chassis. I'm going to use metal-clad resistors, so more of that later. So I cleaned the board. As you can see, the damage, is not much left in the way of tracks or lands left. So my intention now is to try not to disturb these too much, but I'm going to remove those resistors from the top because they're just going to get hot, and it's going to happen again. So I think what I'll do is I'm going to cut those wires off from the resistors themselves. And I think what I'm going to do is to fit some Vero pins, the very small little pins, through the board. So I'm going to drill some 1mm holes close to here and here, and I'm going to put some Vero pins through there and then solder to them, and then I can join wires onto the surface rather than disturb this rather fragile situation that we have at the moment. So I'm going to start doing that now. So I've cut the two resistors off, and I'm going to start drilling some holes now close to these remaining wires. And then I'm going to be able to push a decent pin through there, and that'll be a nice tight fit in that hole and give me some stability to join a cable on the surface. That is really tight. I'm going to have to use a soldering iron with a bit of heat now to push that in. Yeah, that's really rigid. I'll come back when the soldering iron's warmed up. I'll just drill the remainder of these holes with a Vero pin. Oh, the iron's warming up. Oh, we go close to the... There we go. bit of luck we can push pins. So I've drilled a 1mm hole in there, and they've got some flutes on the serrations on the surface of these pins, so they're quite stiff to push in, so they'll form a nice solid base to join some flexible wires on when I mount the power resistors externally. I'm going to use metal-clad resistors, and they'll be mounted on the chassis, and it'll avoid this issue in the future. So I'm just going to put a little bit of solder on there, get a bit of heat on these pins, and then they should just, there we are, they pop in beautifully now with just a little bit of heat. That'll form a nice secure. Oh, they're really tight here there. That's lovely. I'm really happy with that. And now I can just solder to those from their original, these bits of solder here, just to link them with a bit of luck. Okay, I'm just going to solder these pins now to the damaged tracks. There we go. That's lovely. A bit more on there maybe. Yeah, that's beautiful. I can now just see the pins poking through here, so they'll form a nice solid connection now for the flexible wires. I intend to mount these metal-clad resistors on the chassis here, so I'll drill some holes, and we'll do that next. Looking at this board now, you can see that it shows, you can just see a ring in that solder joint. This is a classic formation of a dry joint. There's one there and here. I've already done a few, but I thought I'd show you this one. So this reads reflowing. Well, I'll remove the solder and redo it. These are all part of this circuit where the board has been overheated. So this is basically what's going on in this circuit and why it's getting so hot. It's a truly dreadful bit of design. We're taking 50 volts, feeding it through a 470 ohm 5-watt resistor into a poor little 15 volt Zener to provide us with a 15 volt rail supplying some of the solid state electronics in this valve amp. So there's an awful lot of power being lost there. There's 35 volts being lost across this resistor to take us down to, so there's 35 volts being lost across there, and in terms of dissipation we can work that out in terms of how many watts it is from the formula of V squared divided by R. So if we take V squared, which is 35, times 35 is equal to 1225, and then the resistance is 470, so we put that over 470, and that actually comes out at about 2.6 watts. Now, doesn't sound very much, but of course this is one half of the circuit. This is the positive side. There's also a negative side, so there's two of these resistors side by side, and if you double that, you've now got about 5.2 watts of dissipation. Now that's an awful lot of heat in a small space, and all that heat is traveling down these little tiny wires into that printed circuit board and cooking it, and those PCB tracks are only held on with glue, so the whole thing falls apart. It's a dreadful piece of design to go from 50 volts down to 15 with such a crude crowbar system. So these resistors, I've obviously cut these out, but I'm going to replace them with metal-clad resistors, which will be bolted down to the deck, and that heat will get dissipated into the chassis and won't cause any harm. So I've soldered some wires now onto those Vero pins that I pushed through, and I've also bent the original leads from the old resistors and folded those around the pins as well. So I've got a really solid mechanical lock now, and those are pretty solid. I've used different colored wires for the two resistors as well, so I don't muddle up the plus and minus supply rails when I solder the resistors on. So that's that bit complete. I've also changed these two caps here. The original ones I felt had got a bit overly warm, and I think when you look at that, you can kind of see that the insulation has sort of started to melt on that one from those. Okay, so all the caps are fitted, and now I've got these wires now fitted to where the burnt resistors and the board which was damaged. So I intend now to take these wire wound resistors, these metal clad wire wound resistors, and I'm going to fit them onto the chassis. So I'm going to have to drill some holes to mount them. So I've already drilled two. I'm going to drill some more now in this position. So I've marked them where they need to go, and I'm going to drill them, and then I'm going to tap them, and then we'll put an M3 bolt to hold those on, and then solder the wires on, and then the amp will be ready to go. So one resistor now is fitted. This last fitted really nicely. I've tapped and threaded these holes. They're 3mm fixings, and the other one is going to fit nicely there. So I'm going to remove them now and solder the wires on. I also need to put a resistor in parallel with this. This is a 1K resistor, and what I really wanted was a 680. Unfortunately, I couldn't find any in any of the UK suppliers in stock at the moment. So a 2K2 1 watt resistor in parallel with that will make 680. So I'm going to do that, and come back when I'm finished. So I've got the resistors now bolted in place. So there's M3 machine screws on those. I'm going to check the resistors now they're actually working. So as I said, they were 1K wire wounds because I couldn't buy the 680s I wanted, so I put 1K wire wounds, and I've got a 2K2 in parallel with it, and I hope that's going to give me around about 680. So we'll just check that. Oh, that's not bad. 682, happy with that. And this one, let's try that one. 681, that's not bad. Right, I think the next stage now is to test the amplifier. A few final checks now on the amplifier. I want to reset the bias. So here is the bias test point, and this needs to be 60 millivolts, measuring across those two pins, and that gives me equivalent of 60 milliamps. So that's 30 milliamps per tube. There's a 1 ohm resistor underneath that board, connected in series with the two cathodes. The two cathodes are common. Okay, the amp is powered up. We got 240 volts going in. I'm just going to measure the HT voltage. It's 458. And now we'll check the bias. Across test point 30. So we got 51, so that's slightly low. So I'm just going to adjust that upwards. 57. We can do with 60. We're getting pretty close there. A little bit more. Can't really clip probes on. There you are, 59 point. So I think that's close enough to 60. Lovely. So final check now. The amp is warmed up. It's all reassembled. And I've got a signal generator connected to the input. I've got the amp output connected to my oscilloscope. And I've got my dummy load set to 8 ohms. And I'm just going to run this up now and we'll have a look, see what so we're just about touching 18 volts there. Just to the point of clipping and a little bit of crossover distortion, so we can work out how much output power is now. So that's 18 squared, so that's 18 times 18, which equals 324, and then we divide that by the 8 ohms, and that is 40.5 watts. We've measured the voltage in RMS, and that's 40.5 watts RMS. So that amp looks pretty healthy to me. So I think we can call it a day. Just one more thing I need to do now before I put the back on and sign this off, and that's a electrical safety test. So I'm going to test the earth bond. So that's 0.05. I'm going to test the insulation. That's above 299 megohms. And I'm going to put it on and I'm going to test the load and leakage. So the leakage is less than 0.1 of a milliamp, and the amp is drawing about 0.2 of an amp. I'm measuring 68, probably rise a little bit more as it warms up, 68 VA. So that's all looking good. So I'll make a note of those readings now, and we can put the back on and sign off on this amp, I think.